Hello, welcome back to class. Today, this is investigating gas relationships, the combined gas law. I'm your teacher, James Curtis Dilday II. These are the links for today. We have this presentation, a Google form for the entrance ticket, and a Google form for the exit ticket / homework. You can find these links in the resources that go along with this video. Let's start with the entrance ticket. Here on the entrance ticket, I want you to pause the video, go and do the entrance ticket, and then return to check your answers. Pause the video, go and do the entrance ticket, and then return to check your answers. 3, 2, 1. Okay, let's see how you did. The first question there, we have the law of Gay-Lussac's law, which relates to pressure and temperature. Then we have Charles's law, question number 2, Charles's law. And question number 3 is Boyles's law. All right, very good job. I hope you did well on that. Today's big idea, the macroscopic properties of a gas, pressure, volume, and temperature, are deeply interconnected, and a change in one variable inevitably affects the others due to the kinetic energy and collisions of the gas particles. So what we've looked at before in the previous lessons is how two of these variables, pressure, volume, and temperature, can relate to each other. Either pressure and volume, or volume and temperature, or pressure and temperature. But now we're going to combine everything together to see how all three of them relate. And our essential questions for today: how can we use mathematical models to predict the behavior of a gas when multiple conditions, such as pressure, volume, or temperature, change simultaneously? What does a sudden extreme drop in temperature cause? Why does a sudden extreme drop in temperature cause a sealed can to be crushed by atmospheric pressure? We're going to start here with egg in a bottle. We have a video. I want you to watch the video, and then after the video, you will pause the video and write down a short paragraph explaining why the egg sunk into the bottle. Then you will come back and press play to see a model answer. And remember to take a picture of this work that you're doing to submit in the exit ticket / homework. So let's watch the video. All right, so very good job. As we said before, pause the video, write down a short paragraph explaining why the egg sunk into the bottle, then come back and press play to see a model answer. 3, 2, 1. All right, so here's a model answer. I want you to see what the similarities and differences are between your answer, the answer you wrote down, and this model answer. So feel free to pause the video and check and see how you did. 3, 2, 1. Okay, great job. Here we're going to look at the combined gas law, which is what we're focusing on today. The combined gas law combines 3 different laws, which we've looked at today. You looked at them specifically in your entrance ticket. Let's see if we can remember what those are. So we have Boyles's law, which this is review. Very quickly, I want you to think about what the equation or the formula for Boyles's law is. And I'm showing you the graph there to help you with that. Okay, let's take a look. P1 V1 is equal to P2 V2. So, and remember, 1 is initial and 2 is final. So initial pressure times initial volume is going to be equal to final pressure times final volume. Now that you've checked the graph and you've checked the formula, let's see if you can complete the sentence there. So as blank decreases, blank increases. 3, 2, 1. As volume decreases, pressure increases, which you can see there in the graph. So as the volume is decreasing as we move from left to right, then pressure is increasing. All right, let's do the same with Charles's law. Let's see if you can remember what the formula is. 3, 2, 1. Okay, so initial volume over initial temperature is equal to final volume over final temperature. And let's see if you can fill in the blanks there. 3, 2, 1. As temperature increases, volume increases. Okay, so you can see there in the graph, temperature going up and volume going up at the same time. And we'll do this one more time with Gay-Lussac's law. Think about what the formula might be after looking at the graph. 3, 2, 1. So initial pressure over initial temperature is equal to final pressure over final temperature. And please take a second to try to fill in the blanks. 3, 2, 1. As temperature increases, pressure increases, which you can see there in the graph. And we could put all of this together into the combined gas law, which is where all three are put into the same formula. So we have P1 V1 over T1 is equal to P2 V2 over T2. Okay. And you can see in the bottom right here of the slide, a change in pressure, volume, or temperature causes a change in pressure, volume, or temperature, with the ratio between the two sides of the equation remaining the same. So let's look at solving the combined gas law problem. We're going to go through the steps here for solving the combined gas law problem. And then you can use these steps to solve problems on your own, which you will have to do on the unit quiz. So 1, identify variables, find the initial pressure, volume, and temperature, and the final pressure, volume, and temperature. Then we need to convert to Kelvin. You can see on the right there. And in order to do that, we've looked at this. You need to use the conversion formula given there. Then check units. Make sure that all the initial and final variables are in matching units. If you have volume in liters for the initial volume, the final volume should be the same. If they're not, you need to convert them before plugging them into the formula. Rearrange the equation. I'll show you how to do that. But if you're looking for V2, for example, or T1, you'll have to rearrange the equation so that you're solving for that variable. And then 5, plug and chug. Insert your values into the rearranged equation and solve. Remember to double check your calculator work. And finally, check if the answer makes sense. Look at your answer. Does it make sense? For example, if the temperature goes up and the pressure stayed the same, did the volume increase as expected? If you get a negative number, something has gone wrong. So take a look at and before you submit your answer, make sure it makes logical sense. All right, so here's our first problem. We're going to work this out together. And then after we do this one together, you're going to do one on your own. And you can rewind the video and go back and see how we solved this one together to help you solve the next problem on your own. And you will have to show your work on the next problem and submit that as part of your homework assignment. A weather balloon is filled with helium gas at ground level where the temperature is 22 degrees Celsius, the pressure is 1.00 atmospheres, and the balloon has a volume of 45.0 liters. The balloon is then released and rises to a high altitude where the pressure drops to 0.600 atmospheres and the temperature drops to minus 5.0 degrees Celsius. Assuming no gas escapes, what is the new volume of the weather balloon at this altitude? Let's take a look. Let's find out. So we start first on the right, we can see identify variables. Okay, so we have P1, V1, T1, P2, V2, T2. You can line them up like that on the left side. It makes it easier. Then we fill in the blanks there as are seen in the word problem. And we see, oh, we need to solve for V2. So we write down our combined gas law equation. Oop, I'm sorry. Next is convert to Kelvin, because we do have some Celsius temperatures in there. Using our conversion formula, we convert to Kelvin and write that down with our variables. Now we rearrange the equation after checking the units, and we can check and see that all the units are the same. Atmospheres for pressure 1 and 2, and we have Kelvin for T1 and T2, and P2 is in V1 is in liters, so our final answer will be in liters. Okay. And there, the question does not ask us what units the answer are in, so we can give it as liters and keep it the same. Rearranging the equation, we write the original combined gas equation as seen on the screen. Now we want to get to V2 on its own, so on the right side of the equation, it's divided by T2, so we need to cancel out that T2 or move it to the left side of the equation. So we multiply by T2 over 1. And we do that to both sides of the equation, which you're familiar with doing. And then we do the same to get rid of P2, but it's on top, so we divide by it on the right and the left. And then cross out, and we get our new equation there, which is T2 times P1 times V1 over P2 times T1 is equal to V2. All right? Now we plug in our values and we double check that we write everything correctly and we have the units correct. Then we cross out the units and double check that our answer will be in liters. And the calculator gives us 68.1 liters. Does that make sense? Where our initial volume was 45.0 liters. So we've had a pretty big increase, right? Less than doubling, right? So maybe a 50% increase there. Now let's think, okay, well, what changed? Well, the atmosphere decreased by about 50%, and the temperature decreased a little bit, not too much. So the volume increase there makes sense. It seems reasonable. All right. Let's do a growth mindset reminder. Believe you can, and you're halfway there. That's a quote from Theodore Roosevelt. So you're about to try some calculations. Here's the things. Most mistakes in these problems come from mixing up units or skipping steps. So check your units first, show your work, and believe in yourself. Motivation. You can do this. And remember, go back and watch the video we just did, or go back and watch the problem we just did together to help you if you need help. So let's take a look now at your problem that you're going to do on your own in your notebook with your pen or pencil and paper. And then you're also going to take a photo of that to submit as part of your exit ticket / homework assignment for today. All right. So you're going to do this on your own and then pause the video, do it on your own, and then come back and check your answers. 3, 2, 1. Okay, so let's take a look at a mistake you might have made there, which is noticing that the question is asking for the new temperature to be in degrees Celsius, which is they do that a lot in these problems. So you start with Celsius, you have to convert to Kelvin. When you get your final answer, it will be in Kelvin, but then you have to remember to go back and convert that into Celsius. That's a very common mistake for these problems. All right. We're going to watch a video now, and we're going to kind of switch our focus to laboratory safety. Before we do that, I want you to pause the video and write down 3 to 5 laboratory safety issues that you can see in this poster. And then come back, press play, and see a model answer. Remember to take a picture of the 3 to 5 laboratory safety issues. This will all be included in your submission at the end for the exit ticket / homework. 3, 2, 1. All right. So we've collected a lot of responses from students in the past and put everything here. Go through and see if what you wrote is here. If you wrote something new, I'm really looking forward to seeing it because I'd like to add it to this growing list of issues, laboratory safety issues that students have found. Okay, so now we're going to watch a video, can crush video, where a can gets crushed. After the video, you're going to pause the video and write down a short paragraph explaining the safety procedures that you saw demonstrated in the video. And you'll remember to take a picture of this and to submit it in the exit ticket / homework. Okay, so watch this video and then pause the video and write down the short paragraph explaining the safety procedures and that you saw in the video. Okay, let's watch the video.
Back here. This time what I do is I take this can, I put a little bit of water in here, maybe an ounce or two, here, your splash. Okay, now what I do is I hold it over the flame for about 1 minute. Okay, now you start to see some steam come out of the top, rolling boil, really hot, start to feel it now, it's starting to feel like it boiling, you start to see the steam coming out a little bit better. Get it nice and hot. I want it as hot as possible, I want as much air to come out of the pan as possible, then we start to boil. Okay, now what I'm going to do is I'm going to flip it upside down, I'm going to put it in there, I'm going to put it right at the surface. 2, 3. Not bad.
Oh, that's a great video there. So pause this video, our class video, write down a short paragraph explaining the safety procedures you see demonstrated in the video, and then come back. 3, 2, 1. All right, let's get to the exit ticket. We have the Google form here for the exit ticket. In there is a number 1 is the classwork. So I want you to upload the pictures of all the classwork that you did today. And number 2 is a lab safety question. And number 3 is a writing assignment using a lot of the language that we worked with today. Please do your best. And I've given you some vocabulary to use, and I've given you some sentence frames to help you get started with that writing. And then there's a problem where you'll have to solve a combined gas law, which is very similar to the problem, one of the problems that we solved today. And I know you can do that, and this will really help you be fully prepared for your upcoming Unit 7 quiz. I'm very much looking forward to seeing how you all do on the exit ticket / homework. And thank you for being such wonderful students today. All right. Thank you so much. Bye.